Okay, hello everybody. This is Mr. Sadler, and I'm going to go over the contour maps that are shown on pages 78 through 83 in your lab book. So this is a map that's on top of page 78. So what you have to do is that you have to label all the contour lines first. So there's only one contour line that's actually labeled. Let me get my pen going. And it's this line right here. So what I like to do, what I advise students to do, is to label this line over on the other side of the stream because it's the same line. That's the 180 line. So you have a hill and you want to completely ignore the hill and you want to label all the other lines first before you tackle that hill. So you notice that this contour line is crossing a stream and it's making a V. So the V is pointing in this direction. Is that uphill or downhill? So that's obviously uphill. So if this is 180, then that's going to be 190, okay, and then it goes up. Now another way that I know that it's going up there is anytime you walk away from a stream, you're going up a hill. So I'm walking here, I'm walking in this direction away from that stream, I'm walking up a hill. So I don't even need the contour V's per se. I can just look at, say, for example, if I am standing right here and I'm walking this way, I'm walking up. So 180, 190, blah, blah, blah. So after you label this line right here and after you label this line right here, then you have to use your hill and depression rules to figure out the elevation of that line. Okay, so I'm going to clear my screen. After you label this map, then you have to answer the questions that are here, and then you have to do a profile. So when you do a profile, you're going to have a piece of paper, a scratch piece of paper, and you're going to be putting it right here underneath this line. And on the piece of paper, everywhere that this paper is crossing this XY line, you're going to put a little tick mark with every contour line that crosses that piece of paper. Okay, you see what I'm doing on the piece of paper. So I already know that that's going to be 180. So I write the number 180 on the piece of paper, whatever that number is, and so forth. Okay. Then you're going to take that piece of paper with the information, and you've got all these ticks on the piece of paper. And we already know that the first one is 180. So you come straight up from 180 and you put a little dot. The next one is probably going to be 190. You come up to 190 and put a little dot. So I'm going to let you work on that. But I will tell you that this particular profile, if you do it correctly and if you've labeled your map correctly, you're going to have 4 180 dots in a row. So you're going to be coming up off of a hill. I don't know how high the hill goes. So I should have come up a little bit higher than that. So your profile is going to look like this when you get to this point. It's going to go down, and then it's going to come up like this, and then it's going to make a V, and then it's going to go up, and it's going to continue on its way. So the biggest question that I always get in class is, why does the hill not just jump up like that? And the reason why is because hills don't, or even depressions in this case, they don't suddenly jump up in the real world. If you're walking down off of this hill, it has to round down naturally. And the rule of thumb is that you want to round it down to about halfway down to the next line. So it rounds down, and then you round it up halfway up to the next line. And then if I go back, I notice that I'm crossing a stream right here. So right there, I'm crossing a stream, and I have to show a little V. So that is a stream. Okay, now how you finish a profile is that you just let it end with the last dot that was put on your last little tick that was put on your piece of paper. It's going to be whatever that line is going to be. Okay, so now we move on to page 79. You have to label the map. Again, you ignore this hill and you ignore this depression. You label all your lines first, and then you can use your hill and depression rules to figure that out. Now, in case you're not sure as to what I'm talking about with hill and depression rules, If you look back on page 63 at the bottom, these are where your hill and depression rules are shown. And I think a couple of pages after that, you actually practice hill and depression rules. You have two profiles that you have to do. One is from A to A prime, which is from here to here, and that's supposed to be a straight line. And then the other one is from B to B prime, which I'm assuming that's B prime over there. I've got my lab book right here. Yes. Okay, so B to B prime is going to be way over there. So I would advise you to use a ruler and to do the little piece of paper or the little trick and stuff. And you notice that A prime is going to cross one stream, but B prime is going to cross two streams. So the B prime, I don't exactly know where the line is going to be, but you're going to be crossing two, you're going to have two streams in this one. 1, 2. Okay? Moving on, this is a volcano. This number right here is a typo, so ignore that. So I'm scratched it out. So you label all your lines, you're going up to the volcano, and this is one of your hill and depression rules. This is 900 and 900, and so this number is also, this line is also going to be 900. So again, look at the hill and depression rules, make sure you know them and you're comfortable with using them. So then you do a profile and then you answer the questions. A real quick thing about drainage patterns. At the back of your lab book, there's pictures of drainage patterns, but let me just kind of make it simple for you. I'll try my best to draw something here. Dendritic is like the veins of a maple leaf, like we talked about in class. So this is the most common drainage basin pattern. Radial is usually what you find off of a volcano, which is what this is. Okay. Trellis, I didn't talk about that in class, but trellis kind of has this appearance to it. It kind of has alternating tributaries. Okay. A lot of students get confused with number 3. Is the land between the repeating contour lines higher or lower than the surrounding contours? It's asking about this land right here. Is this higher or lower than 900 is what it's asking. Okay. Now on this map on page 81 at the top, I would advise you to take it in quadrants. But before you do that, you have to remember the rule that contour lines occur in pairs on each side of the stream. So if this is 50, this one's also going to be 50, and it's obviously the same line. Contour lines occur in pairs. This is 50. There's 50 here. So I would label the Dickens out of a single line and then take it in quadrants. Work that part, and then jump the stream, work that part, jump the stream, work that part. Answer the questions. Okay, another volcano. It should be pretty simple based on the volcano you just did earlier. The geologic feature shown on the map above, is this a volcano, hill, or mesa? So I would refer you back to that on top of page 80. Now, this map at the top of page 82 is completely optional. You don't have to do it if you don't want to do it. But let me try to get you started on the first line. Contour interval is 10 feet. The first line you're going to draw is 30. And I do want to teach you an advanced trick with this particular map. Okay, so it's going to make a V here, and it's going to go off that way. That's exactly what the 30 line is going to do. Now, you notice that I have some things written here in pencil, and apparently I helped some students in the classroom before this. So what I like to do is erase the screen. Now, you have a 27 here, and you notice that I wrote a 27 on the opposite side of the stream. So this is using the assumption that a stream is V-shape, and if you have a buddy that's standing at 27 feet above sea level over on this side, then another buddy is going to be at the same elevation on the other side of the stream. So for example here, equidistant on the other side is going to be 30. And the reason why it's good to know that is because you can do this little trick even on the lab test, or you can kind of eyeball it on the lab test. And it would help guide you when there's very few points to help guide you. Okay, you work this map, there's 500, you're going down, again, as you're going down toward a stream, you're going down, and then you're going away from a stream, you're going up. Okay, the biggest thing in this map is the difference between a mesa and a hill. So a mesa in Spanish is tabletop. So between X and Y, which one would be the mesa? So you have to answer that. Okay, this is the final map on page 83 at the top. And this is where I teach you officially how to do stream gradient. So you label your map. One thing you're going to have to do is what I've already done with my lab book, which is something you have to do with your lab book. You need to add a 240 line, and that will make the elevation of the lake right there at that point at 240. Okay? So you label all your lines, and you answer questions 1, 2, and 3, and then we're ready for question number 4. What is a gradient of the main stream? So this is the main stream right here. Okay. What is the gradient of that stream from the point, the tributary? This is the tributary. This stream here is the tributary. What is the gradient of the main stream from the point the tributary intersects the main stream? The point the tributary intersects the main stream is right there. That's going to be your E1, which I've already got it labeled in the map. To the lake. So E2 is going to be here at the lake. So I don't know if you watched a previous video that I recorded, but elevation, the equation is E1 minus E2 divided by D in miles. So this one's in feet, and this is in miles. Okay, so E1 minus E2. So whatever elevation that is, minus whatever elevation that is, which is going to be 240 in this case. And that will spit out the number here, which is the number for the rise. So gradient is basically calculating slope. So it's the rise over the run. And to put that in a pictorial type of way, this would be the rise. In feet. And from here to here is the run. So how far does it go in miles? Okay, rise over run. So E1 minus E2 will spit out some number, and then you're ready for D in miles. Well, hopefully you have a ruler at home or some way of calculating distance in inches. Let's say that's 3 inches. You notice the map scale is 1 inch is 2 miles. So if you've measured 3 inches, then 3 inches is going to be 6 miles. So you plug that into the equation, and it spits out a number. And the number that it spits out is going to be in units of feet per mile. It's the gradient, how you report gradient. Okay, you also do the gradient for the tributary stream. Okay, so that is the end of this presentation, and I thank you very much.